Assalamualaikum and hi everyone. In this lesson, we are going to discuss the term orbital, and then we are going to see where are the possible space in an atom that we could find electron by knowing the principal quantum number n, the angular momentum quantum number L, magnetic quantum number M or ML, and electron spin quantum number S or MS. So by studying these four quantum numbers, later you will be able to predict where is the positions or locations in an atom where we could probably found the electron. And lastly, you must be able to sketch the 3D shapes of orbital S, P, and D. So please stay with me until the end of the video and have fun in your learning. In this video, we are going to discuss quantum mechanical model. So this model is introduced by Erwin Schrödinger to solve the problems of finding electrons. It is a mathematical model which predicts the probability of electron location and path in electron clouds. So in a simple word, we can see that this model can help us to identify which space or region in an atom where we could possibly found electron. Okay, di manakah ruangan yang mana kebarangkaliannya kita boleh jumpa elektron di dalam sesuatu atom. Okay, so this is not similar to the one that you have learned in the Bohr atomic model. According to Bohr atomic model, he said that we can find the electron specifically at N1, N2, N3, and so on. Meaning that when electron is circling the nucleus at N1, meaning that that is the exact position where we could find the electron. This is what proposed by the Bohr atomic model. But according to quantum mechanical model, maybe we can have the same concept of energy level n equals to 1. But in this region n equals to 1, not all positions here is possible for us to find the electron. Maybe we can find the electron at this position. And then when we go to this position, okay, maybe at this position pula, we cannot find the electron anymore. Okay, and as we move to the other position, yes, maybe at this position we could find the electron some more. Okay, and so on. So meaning that in an atom, not all positions in this orbit we could find the electron. Okay, there is a specific region in atom that we could probably found the electron. Okay, ada ruang-ruangan yang tertentu di dalam sesuatu atom di mana kita probably can find the electron. So this is what we are going to discuss in quantum mechanical model. We are going to find the position or space in an atom where we could probably found the electron. Here are the comparison between Bohr atomic model and quantum mechanical model. Orbit is the term we use in Bohr atomic model, and orbital is the term in quantum mechanical model. But these two terms is actually referring to the same concept, that is energy level. So both orbit and orbital, they are actually referring to energy level. According to Bohr theory, orbit refers to a specific path that electron move. So we have N1, N equals to 2, N equals to 3, and 4, and so on. So those orbit is actually the place where the electron moves, the circular orbit where the electron moves around the nucleus. Okay, so pergerakan elektron dalam Bohr atomic model berlaku pada specific orbit. Okay, specific path that we call an orbit. But in quantum mechanical model, there is a region in space about the nucleus where there is high probability of finding electron. So according to this model, kita tak boleh kata electron can be found at n equals to 1. No, okay, tak boleh. Okay, there is a possible space in an atom where we could probably found the electron. Ada ruangan-ruangan yang tertentu, okay, pada energy level 1, energy level 2 di mana kita adalah possible untuk jumpa electron. And then electron is located at the same distance from the nucleus. And for quantum mechanical model, there is certain space from the nucleus where probable to find the electron. So to make you understand better regarding these two comparison, so let us see this image. So according to Bohr atomic model, if electron is moving in circular orbit n1, so this will be the fixed position between the electron and the nucleus. So at all positions here, electron will move circling the nucleus at this fixed position. And if electron is moving on n equals to 2 in this orbit, so this will be the fixed position between the nucleus and the electron on the second orbit. So as the electron moving, nucleus at n2, so this will be the fixed position between the electron and the nucleus. Meanwhile, in quantum mechanical model, okay, you can see that there is no distinct orbit. Okay, macam ni you boleh nampak orbit yang jelas, yang nyata, circular orbit. But in quantum mechanical model, we have no distinct orbit. Okay, tak ada orbit yang nyata. So what we have is only electron cloud. So if you can see from this image, we can say that this is the area where there is high probability for us to find the electron. Okay, kenapa? Due to the higher intensity of the color. Alright, and as we move far from the nucleus, the intensity of the color will be faded, showing that these are the areas where there is low probability to find the electron. So this is consistent with the concept of electron and nucleus, okay, because electron has negative charge and the nucleus has positive charge. So for the area that closest to the nucleus, we could find most electron here. But if we move far from the nucleus, we will find less electron at this region. Okay, so this is the form of the electron cloud as proposed by Erwin Schrödinger in his quantum mechanical model. Atomic orbital, according to quantum mechanical model, is a three-dimensional region in space around the nucleus where there is high probability of finding electron. So we do have shapes for the orbital. Okay, so by looking at these shapes, we can determine where is the space around the nucleus where we could find the electron. Daripada bentuk-bentuk orbital ini, kita boleh predict, kita boleh identify di manakah ruangan-ruangan di dalam atom yang kita boleh possible untuk jumpa electron. And orbitals is differ from one another in their energy, shape, and spatial orientation in clouds. Spatial orientation refers to the way of the orbitals are arranged in space, meaning that they need to have axes, whether at axis X, Y, and Z. In order to know the region in the orbital that we could probably found the electron, hence we need to study quantum numbers. The quantum mechanical model studied the region in space in an atom where there is high probability of finding electron. Okay, so model ini mengkaji tentang ruangan-ruangan di dalam sesuatu atom di mana kebarangkalian untuk kita jumpa elektron adalah tinggi. Kerana we cannot say that electron must be found at N1 sahaja. No, that is Bohr atomic orbital. Okay, so according to the quantum mechanical model, there will be a specific region in space where we could probably find the electron. So, to know where is the region that we could find the electron, so hence now we have to study these four quantum numbers. So, these four quantum numbers will help us to identify that possible region where there is high probability of finding the electron. So, 4 quantum number ini akan membantu kita untuk mencari di manakah lokasi-lokasi di dalam atom where we could probably jumpa elektron dengan kebarangkalian yang tinggi. So these four quantum numbers are principal quantum number n, angular momentum quantum number L, magnetic quantum number ML, and spin quantum number S or MS. So by considering all these quantum numbers, we can identify the location of the electron in an atom. Okay, dengan mengkaji keempat-empat quantum numbers ini, kita boleh predict di manakah lokasi-lokasi yang kita boleh jumpa elektron di dalam sesuatu atom. Let's start with principal quantum number n. Principal quantum number n is the other name for energy levels or shells. So the number of n determine the size and the energy levels of n orbital. The allowed values of n are positive integers starting from n equals to 1 until n infinity. So the greater the value of n, the higher the energy levels, the bigger the size of the orbital, and farther the orbital from the nucleus. We can also relate the value of n, principal quantum number, with the one that we have learned in Bohr's atomic model. So let's say here we have n equals to 1, n equals to 2, and n equals to 3. Moving from n equals to 1 to n equals to 3, the number of n will be increases, showing that the energy levels increases. So at n equals to 3, which is third energy levels, the distance between the third energy level is the farthest from the nucleus. And you can see also the size of the third energy levels is bigger than the size of the first energy level. We can also use this letter designation to symbolize the principal quantum number n. The capital K refers to the first energy level or orbitals, L is for second energy level, M for third energy level, and the list will goes on. Moving from the first principal quantum number to the seventh principal quantum number, showing that the greater the energy levels, the greater the distance of an electron from the nucleus in the orbital, and the larger the orbital. So if we have electron on the seventh principal quantum number, that electron will experience much less attraction forces with the nucleus as we compare to the electron that located at first principal quantum number. This is due to the greater distance between seventh principal quantum number with the nucleus. But the electron that is located at the first energy level or first principal quantum number will experience greater attraction forces with the nucleus due to the closest position with the nucleus. To know the maximum number of electrons that can occupy the principal quantum number, we can use the formula of 2n squared. By substituting the value of n into the formula, we will have 2 electrons that can reside in first shell, 8 electrons that can be in the second shell, 18 electrons in third shell, and 32 electrons in fourth shell. Second quantum number will be angular momentum quantum number L. So this quantum number will give us information regarding the shape of the orbitals. If in principal quantum number, you have the idea regarding the size of the energy level or orbital, but in angular momentum quantum number, you will have the information regarding the different shape of the orbitals. The allowed values of L will be from 0 until n minus 1. So the value of L is dependent on the value of principal quantum number n. L divides the shell or energy level into smaller groups of orbitals called subshell. By knowing the value of L, you will be able to identify how many more suborbital in principal quantum number. For example, in principal quantum number 2, which is n equals to 2, you will be able to know how many suborbital that reside in principal quantum number 2. In the same principal quantum number or energy level, we can have different shapes of orbital. This is because the value of the L will be different for the same value of N. The information in this table tells us regarding the different value of L with their respective orbital shape. The value L equals to 0 refers to S orbital, and the shape of the orbital will be in spherical. This is the spherical shape of S orbital, and you must draw the axis as well. The intersection at the center refers to the node, that is the location or position of the nucleus. L equals to 1 refers to the p orbital, and the shape of p orbital is in dumbbell. Dumbbell shape of p orbital has two lobes, dua kelopak. And the intersection at the center is the node, that is location of the nucleus as well. And when value of L equals to 2, this is referring to d orbital, and the orbital shape will be in cloverleaf. D orbitals have 4 lobes, 4 kelopak, and the intersection at the center is the nucleus. So, from the value of angular momentum quantum number L, you will be able to know the symbol of the orbital with their respective orbital shape. This orbital shape is in three-dimensional shape. So, when you are about to draw your own orbital shape, make sure you have to draw the axis as well. Next will be the magnetic quantum number ML. So ML determines the orientation of orbitals in space, that is permitted values of orbitals or particular value of L. In a simple word, we can say that this ML, from this ML, we can identify the pecahan of this L. Okay, so ML ini adalah the way we get to know the pecahan of this L. Alright, so from this ML juga, you will find the orbital that have the same energy level and shape. And the allowed values of ML will be from negative L to plus L. So in order to get the values of the ML, you have to refer to the value of L here. Okay, so these two values, they are interrelated. So to know how does the value of L relates to ML, you can see from this relationship. So to get the value of ML, the value must be from negative L until plus L. So for example, if the values L is 0, so the ML can take the value of 0 only. Okay, because here we don't have negative 0 until plus 0 definitely. Okay, so when L is 0, ML can only be 0. So here we have satu angka sahaja. Okay, bila satu angka bermaksud, okay, we have one orbital in S subshell. Because L equals to 0 is referring to S orbital. Okay, so in S orbital, when the value of L is 0, ML can take only the value of 0. So since here we have satu angka, bermaksud we will have one orbital in S subshell. And if L equals to 1, L equals to 1 is referring to P orbital. So for L equals to 1, ML can take the value from negative L until plus L. Okay, so how to find the value? So for L equals to 1, the ML value will take the value from negative 1 until plus 1. So daripada negative 1 nak pergi ke plus 1 tu, dia akan lalu number negative 1, 0 and plus 1. So here we have how many angka? 1, 2, 3. So this angka is actually represent the sub place. Okay, sub tempat. Okay, di dalam L tersebut. So dalam L1 ini, kita ada lagi 3 pembahagian tempat. Okay, ada pembahagian lagi 3 tempat. So ML is -1, 0, +1. So here we have 3 numbers. So for these 3 numbers, they represent the 3 orbitals in p subshell. Okay, 3 number ini merujuk kepada pecahan orbital di dalam L equals to 1. Okay, and if L equals to 2, ML can take the value from -2 until +2. So now, list down apakah number-number yang terlibat daripada -2 sehingga +2. It is -2, -1, 0, +1, +2. Okay, so this is just mathematical order. Okay, susun balik apakah nilai yang wujud di antara -2 sehingga +2. So from these numbers, we can see that we have 1, 2, 3, 4, 5. 5 numbers. 1, 2, 3, 4, 5. Okay, so these 4 numbers, okay, referring to 5 orbitals in the subshell. So apabila L equals to 2, this is referring to the orbitals. So do we have pecahan of tempat di dalam d orbital? The answer is yes. Why? Because if L equals to 2, ML will take the value from -2 until +2. And how many numbers associated in this range? We have 5 numbers over here. So these 5 numbers is actually referring to another 5 suborbitals in the orbital. So for these 5 suborbital and these 3 suborbital here, we call it as degenerate orbitals. So what is degenerate orbitals? Degenerate orbitals are orbitals with the same energy level. Lastly will be electron spin quantum number ms. The spin quantum number represents the spin of electron in the same orbital. And there are 2 allowed values only. They are +12 and -12 for clockwise and anti-clockwise. So we can see in this example, in one orbital, we can have 2 values of spin quantum number. The first one is +12 and -12. So from these 2 values in one orbital, we can see that in a single orbital, it can occupy maximum of 2 electrons. Okay, in one orbital or in one suborbital or subshell, we can occupy maximum of 2 electrons. So now you have studied all the concept of all these quantum numbers. So by knowing these quantum numbers now, you are able to predict where is the location that we could find the electron in an atom. Okay, because kalau kita ada satu atom di sini, okay, contoh here we have N1, N2, and N3. So by looking at N3 for example, okay, you dah tahu N3 tu maksudnya nilai N. N tu principal quantum number persamaan dengan 3. So by having this value of N, you must consider pula the value of L. Okay, sebab N dengan L, they are interrelated. So to know how many tempat, okay, that we could find the electron pada N equals to 3, you have to study the value of L. Okay, adakah value of L itu adalah 0 ataupun 1 dan sebagainya. Because if we have L equals to 0, then we can have the s orbital. If we have L equals to 1, then we will have the p orbital. And then later on, to know how many space in s and p orbital that we can occupy with electron, you will study the value of ml, because L and ml here, they are interrelated. So by knowing the value of the ml, you will know what is the subshell, okay, of the s and p. Apakah tempat-tempat, pembahagian tempat di dalam s dan juga P yang kita boleh jumpa lagi elektron. Okay, so probably pada ML ini, you boleh jumpa degenerate orbital. And later on, after identifying the ML, you must consider the value of MS as well. Okay, because in one orbital, we can maximize occupy as much as 2 electrons. Why? Because the value of the MS, okay, can only have two values, plus half and negative half. Okay, meaning that in one orbital, we can maximize as much as 2 electrons. Now, let us see the relationship between the value of N, L, and ML. So for the value of N, how could we identify the value of L and ML? The reason why we need to relate the value of N, L, and ML because from these values later, you will be able to identify the specific orbital that we could find the electron in an atom. Okay, dengan melihat kepada nilai N, L, dan ML yang kita ada, kita boleh predict di manakah lokasi di mana kita boleh jumpa elektron di dalam sesuatu atom. Lokasi tersebut kita panggil sebagai orbital. Okay, let's start with the first value of energy level, which is N equals to 1. So for the values of N equals to 1, the L value will be from, so if you still remember, L will take the value from 0 until N equals to 1. So in this case, when the value of N is 0, when the value of N is 1, so L values will be 0 only. And then for the value of ML, ML we take the value from negative L until plus L. And since here we have the value of L is 0, so the ML value also will be 0. To get the label of this orbital, you have to consider the value of N and L. So here we have N is 1. L is 0. If you still remember, L0 is the symbol for S orbital. So the label of orbital here will be NL, which is 1s. Okay, how many numbers of orbitals or subshells in 1s? So to know the number of orbitals or subshell in 1s, you have to refer to the value of ML. So how many numbers do we have here? We have one number only. So bila one number ini bermaksud kita hanya ada sebanyak satu orbital. Okay, so this one orbital is actually referring to this orbital. Okay, so untuk nak illustratekan bagaimanakah bentuk orbital ini, okay, memandangkan kita ada satu orbital untuk satu S, maka kita boleh tulis sebagai satu palang, labelkan satu S di bawah. Menunjukkan bahawa palang ruang dekat atas ni adalah tempat di mana kita boleh isi dengan elektron. And this is our orbital. So in this one orbital, we will have satu tempat sahaja. Okay, satu orbital. And if you relate dengan the concept of MS, iaitu magnetic spin quantum number, in one orbital, it can maximize diisi sebanyak 2 elektron. So the answer will be 2 electrons. Okay, so to get the answer for this maximum electron, you can also relate with this formula, 2n squared. So by knowing then the value of n here, which is 1, okay, you can get the same maximum number of electrons in 1s orbital. So there are two ways to identify the maximum electrons in orbital, okay, and in energy level. So by using MS concept, magnetic spin quantum number concept, by knowing the number of orbitals, you can identify the number of electrons in that orbital. And to know the maximum number of electrons in one energy level, like this, you can also simply use this formula 2n squared. That will give you the same answer. Okay, so now we can see that when it is at first energy level, we only have one orbital. So this is the orbital where there is possibly we could find the electron. Okay, ini adalah tempat di mana kebarangkaliannya tinggi untuk kita jumpa elektron. Di mana? Pada orbital 1s. Bentuknya apa? S bentuknya adalah spherical. Okay, let's move to energy level 2, which is n equals to 2. So when n equals to 2, the value of L will be from 0 until 2 minus 1, which is 1. So you have to list down the value from 0 until 1, which is 0 and 1. For the value of the ML, you have to solve for these values separately lah, okay, individually. So when n is 2, L is 0, so ML will be 0 as well. And for the level of orbital here, it is NL. So here we have 2 dengan L is 0. So L0 refers to S orbital. Okay, L1 refers to P orbital. So for this N2, L is 0. Level of orbital here will be 2S. 2s orbital. And how many orbital or subshell in 2s orbital? So hence here you have to refer to the value of ML. Okay, refer to the value of ML. So in the value of ML, we do have one number. Bermaksud, kita ada satu tempat atau satu orbital sahaja untuk diisi dengan elektron dalam 2s. So 2s pun ada berapa banyak orbital? We have one orbital only. So, by having this one orbital, you can identify a maximum number of electrons to be filled in this orbital, which is 2 electron. So, ingat, satu orbital, we can maximize EC with 2 electrons. Okay, let's move to N2L1. So, for N2L1, the ML value when L equals to 1 will be from -1 until +1. So now you have to list down all numbers from -1 until +1. So how many numbers do you have? We have 3 numbers. Okay, we go to the level of orbital first. So for the level of orbital, which is NL, it will be 2p. So how many orbital or subshells do we have in 2p? So you have to refer to the value of ML, which is here. Seems we have 3 numbers over here, meaning that there are 3 subshell in 2p orbitals. Okay, so macam mana nak menggambarkan 3 subshell of 2p orbitals tu? Kita buatlah 3 tempat separate macam ni. Okay, so 3 tempat ini merujuk kepada apa? Kepada 2p orbitals. If you still remember in our previous content, okay, slide sebelum ni. So for the one of the L value yang having more than 1 numbers like this, kita akan panggil this orbital sebagai degenerate orbitals. Orbitals that having the same energy levels. Okay, now, how many electrons do we have in these 2p orbitals? So the concept is, in one orbital, it can maximize diisi dengan 2 electron. So here we have 3 orbitals. So meaning that you have to times 2 for each of this orbital. Okay, so 3 times 2, 6 electrons. Okay, so 6 electrons are the electrons that can be found in 2p orbitals, and 2 electrons to be found in 2s orbital. In total, for n equals to 2 energy level, we're going to have as much as 8 electrons. Okay, kenapa 8? Sebab daripada formula di atas. Okay, 2n squared. Okay, so we have as much as 8 electrons in second energy level. Dan bila kita pecahkan lagi, kita study lagi apa yang kita ada dalam second energy level or second principal quantum number, we do have orbital 2s dengan 2p. Dan dalam 2p, ada lagi pembahagian dia punya degenerate orbitals. Okay, so in 2s, we will have as much as 2 electron. Dan dalam 2p, we can fill as much as 6 electrons. Okay, so apa yang awak buat ini? Ini adalah orbital kosong. We are now going to identify the possible orbital that we are going to fill with electrons. Yang boleh diisi dengan elektron. So ini adalah our proposed orbital. Okay, next. When n equals to 3. So when n equals to 3, L value can take the value from 0 until 3 minus 1, which is 2. So you have to list down all the numbers. So L will be 0, 1, and 2. So when L is 0, that is s orbital, L1 is p orbital, and L2 is d orbital. Okay, so let's do it separately one by one. So when n is 3, L is 0, ML here will be 0. So the symbol of the orbital or label of the orbital will be N3LO, which is S. So you're going to have 3s orbital. So in 3s orbital, how many orbital do we have in 3s? So here we have one number. One number meaning that we only have one orbital. Merujuk kepada satu tempat or satu orbital dalam 3s. Okay, now, so how many electrons can we fill this one orbital? Definitely we can fill with 2 electrons. Okay, next for L equals to 1. For N3, L equals to 1, the ML value can take from negative L until plus L. Okay, label of the orbital will be 3p. So ML has 3 numbers, meaning that you are going to have 3 subshell here. Okay, so 3 tempat. 3 tempat tu macam mana? Ada 1, 2, 3. So these are 3p. And again, this is one of the degenerate orbitals. Okay, now, how many electrons can we fill this 3p? So since we have 3 orbitals, so 3 times 2. So here will be 6 electrons. Lastly, for N3L2. So for N3L2, so when we have the value of L equals to 2, the number of ML will be from negative 2 until plus 2. So the symbol will be 3D. And how many orbital or subshell do we have in 3D? Okay, you have to refer to these numbers. So here now we have 1, 2, 3, 4, and 5 numbers. So 5 numbers meaning that we have as much as 5 subshell in 3D. Okay, so we can draw the subshell as 1, 2, 3, 4, 5. So 5 subshell in 3D. So how many space that we could fill with electron in 3D? We have 5 orbitals over here. Okay, so the total number of electrons that can we fill in this 5 orbital will be 5 times 2. So that will be 10 electrons. So from this justification or determination, you could identify how many electrons that we can fill in this specific orbital. Okay, so to calculate the total number in this n equals to 3, so here will be 18 electrons. And to get this 18 electrons, you can simply tambahkan these values ataupun you boleh cari daripada formula 2n squared over here. So from this activity we did just now, we can identify that at n1, we can have 1s orbital. At n2, we can have 2s and 2p orbital. And at n3, we can have 3s, 3p, and 3d orbitals. So these orbitals are actually the three-dimensional region in space in an atom where we could probably found the electron. So ini adalah tempat-tempat di mana elektron itu boleh berada di dalam sesuatu atomic orbital. In first energy level, or n equals to 1, there is one orbital that is 1s. In second energy level, that is n equals to 2, there are 2 orbitals that are 2s and 2p. And in n equals to 3, there are 3 orbitals that can reside with electron. They are 3s, 3p, and 3d. Okay, so kalau awak recall balik of what you have learned in secondary school, you dah belajar sebelum ni Okay, apabila N1, okay, kita boleh ada sebanyak 2 elektron. Bila N2, kita boleh isi maximum of 8 elektron. Bila N3, we can fill maximum of 18 electrons. So, this is consistent dengan apa yang you belajar in secondary level dulu. Di mana dalam awak menyusun elektron, you akan susun dalam susunan 2, 8, 18 dan seterusnya. Okay, kenapa we have this kind of arrangement? Because in N1, we can maximize field with 2 electrons. N2 maximize field with 8 electrons. Dan pada N3, you can maximize field with 18 electrons. This arrangement in quantum mechanical model. Okay, so for this level, okay, you dah belajar in details macam mana nak identify orbitals yang wujud pada setiap energy levels. So why do we need to know these orbitals? Because kita nak cari apakah location, okay, ataupun region in the atom yang mempunyai kebarangkalian untuk kita jumpa elektron. So these are the places or region in an atom where there is high probability for us to find the electron in an atom.
Thank you for watching, everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning, and remember, chemistry is easy and fun.